Hello boys, today I'm going to show you how to assemble your distribution board. So this is a 16 module. I have 3 RCD, it's 2 pole 63 amp, and I have isolator 63 amp and 132 circuit breaker and 425 amp circuit breaker. And let's start. This is the inside. I need to assemble this first, and then I'm gonna take all the breaker, isolator and RCD and install it inside the box. There it is. Now all I need to do is the wiring, so I will do the wiring and then I will explain why I put this in this order. Okay, and here it is, a complete wiring. So let me explain now. This input here from to the isolator, so the input will come from my electrical meter. Okay, the main input will be here, and then you can see my free RCD. So why I use 3 of them is because when you have, there's one line which is there's a failure in one line, so only one sector will be off. So let's say everything is on, okay, and let's say this breaker here, there's a fault in that room, so when it will trip, only one room will be switched off, the rest will still be on. Okay, so let's say I use only one RCD and then the rest is a breaker, circuit breaker. So if the RCD trip, let's say all these 5 breaker was on the same RCD, so everything will be blackout. Okay, so the wiring is very simple. From the output of the isolator, I just feed the 3 main RCD from here, output to input, again from the output here, and feed the input of this RCD, and the third one also is the same. Now when you switch on this RCD, it will control only the breaker after it. Okay, so when this is on, this is one room is on. Okay, let's say this one is for the living room, so this is for the living room, and let's say we're gonna switch this on, and the power from here will feed this RCD and goes to these 2 input for these 2 breaker. So let's say this is room 1 and room 2. Okay, so if there's a problem in room 2, only room 2 will be blackout. Now if there is a short circuit, well, not really a short circuit, but a faulty, a ground fault, so this one will trip. Okay, so those 2 rooms won't be on, but the rest will still be working. The third one will be the same, so this RCD will control these 2. This will be the electric shower, and this will be the kitchen. Okay, so I use 6mm for the input feed to feed the RCD. This is 6mm wire, and the output from the RCD, I'm using a 4mm. Okay, and then it feeds to the breaker because it's only 25 amp. Okay, so 4mm is enough to give such amount of current. Okay, and here is the cover. So after placing this, should be like that. Okay, I just label everything here. This is the isolator, RCD1 control the living room, RCD2 will control room 1 and room 2, and RCD3 will control the shower and the kitchen. Okay, so I had to change this. Well, I had to do this for a customer because I'll put a picture here on the screen. You're gonna see his previous distribution board is very unsafe, so I will replace this to that one. Okay, and then I need to do his house wiring again because you see here, so these are the output. Okay, so all the input on the top and the output is here on the bottom. So we have breaker 1, breaker 2 here, 3, 4 and 5. So these will be the output, and we'll go to the appliance, to the room. Okay, so this method is a little bit different. I'm using each room with a breaker. So basically this electrical outlet, the lightning, will be on the same breaker. Then if, like I say, if there's a problem in the room, I will check only this line. So let's say kitchen is faulty, so switch off kitchen. I'll check the outlet or the lightning. Then it will be very easy to find the fault instead of other type of electrical. So what some electricians do, they connect like 3-4 outlet together and will be controlled by a breaker. So let's say in one room you have 2 sockets, and then in another room you have another 2 sockets. So you need to check all those sockets here. You have to change from room to room instead of staying in the same room. And with this method, you're gonna stay in the same room and check the electrical instead of moving from one place to another. So I like this method. This method is much better. I like it. It's very easy to see the fault finding, to do fault finding, and I think it's less cheaper as well. And this here will be my ground, my earthing. So all my earthing will be connected here in on this connection, and then the main will be here and go to the ground, the earth rod. Okay, now I will try to apply an input voltage and show you guys how the breaker or the RCD work, so you can have an idea which one trip when there's which fault and which one trip when there's other type of fault. Okay, so I just use my outlet to inject a voltage here. Let's assume I already placed this at my customer place, and I'm gonna show you how it's gonna work. Okay, and what kind of fault, which one will trip according to what kind of fault you're having. So right now, this is my multimeter. I have input here. Okay, my input will always be here on the isolator. Okay, let's check for voltage. I have like 234 volt. Okay, now let's check everything is good. Live and ground, it should be the same voltage. Okay, 229 volt. And now let's go neutral to ground. This is how you check if your ground is good or not. So I have 7 volt through my ground and neutral, 7-8 volt. So if it's under 10 volt, it's good. If it's above 10 volt, that means there is some fault, some problem in your appliance. Okay, now we have input voltage here. Okay, now on the output, by switching this on, I should supply voltage to all the input of the RCD. Remember, output to output here to input, and so on. So my RCD should be powered. Good. This one as well. Good. And this one as well. Okay. Now it is off. That's why we don't have any voltage going to the breaker. If I check this breaker here, which is controlled by this RCD, there's no voltage. Okay, by switching this on now, should have voltage here on the input. Okay, on the output, no voltage because nothing, I didn't switch it on, and there's no load. By switching it on, you can see I have voltage. Okay, so this is how it's working. Now let's test if let's put a load in the output. Okay, I have this bulb. Okay, just to wire from the terminal to the breaker. I use crocodile clips to connect it. So this one goes here, positive, and neutral goes here. Okay, so like I said, isolator, RCD, and then by switching this on, my bulb should go on. There you go. Okay, so now we have voltage. So let's say there is a fault, there's a problem in your circuit, there's your refrigerator is not good, any appliances, let's say there's a leakage. So by doing a simple test, you can test if your RCD first is if it's good or not. Well, you can press this button as well, it's a test point. By pressing this, it should switch off. If you press this button, it doesn't switch off, that means your RCD is dead. Okay, I'm gonna switch it back on. Now let's do the fault test. Okay, the fault test is basically you have a leakage between neutral and earth. Okay, so if there's any leakage, let's say my neutral to earth here, look what will happen. My RCD trip. So this is very important to have. So the leakage can be as well if I touch the wire with my bare hand. Okay, if I touch the wire or anything, any electronic in the any electrical in the house, so once the current goes through me, the RCD will trip immediately. So you will get a very little shock, but you won't electrocute. Okay, so this is very important. Now let's say everything is on. Okay, this is on. Remember, this one controls these two breaker and that one controls these two breaker. Okay, so I separate everything. Now let's say we have a fault in the, I don't know, in the kitchen. Okay, let's say the fault is in the kitchen. Let's touch kitchen neutral to earth. So which one will trip? Can you guys answer me in the comment real quick? Or you can pause the video and tap your answer. So which one will trip? Which RCD? 1, 2, or 3? Okay, so I'm gonna do it right now. See, my light's still on, these two still working, and my RCD number 3, which gonna trip. So let's say I didn't have these two RCD, right? I use only one RCD. And all the connection, all the breaker, 1, 2, 3, 4, 5, gonna be on the same RCD. So when it's tripped, everything will be black out. There will be no electricity going through. The whole house will be dark. So this is why I separate the circuit. It's like only one part of the house can be switched off if there is a leakage. Even for this one, let me try this one. So let's say this one was for, let's say room number 2. This is room number 1, this is room number 2. Room number 2, there's a failure to ground and it trip. See, so this one, these two controlled by this RCD, these two breaker controlled by this RCD, this one breaker controlled by this RCD. And there you go. This is very simple and straightforward to understand. And one more thing, if you have a short circuit between live and neutral, okay, so I'm not gonna do the test. Let's say live and neutral, the wire touch together, so the RCD won't trip. It won't be the RCD. The RCD will stay on. When this is on, you short circuit these two wire, red and blue, or I mean red and black or blue and brown. This one will trip the breaker because the limit is 25. So by having a short circuit, the amp will increase above 25 amp, and then it will trip this one. The RCD will never trip. The RCD is designed to protect you against any electrical shock, but the breaker gonna protect the circuit if there's a short circuit. Okay, it will protect the circuit only. So it won't destroy anything else. Your wire won't burn, it won't melt. So this is a use of the breaker. Thanks, guy. I think that is quite a long video. Please subscribe and comment. Cheers, guys. Bye.